Welcome to the second section of the course. This section is called Searching in Graphs. In the previous section, we saw how we can implement graphs and trees, and in this we will learn about algorithms that we can use to search these graphs. In this section, we will look at the theory behind breadth-first search, how it works, and then we will see how we can implement breadth-first search in the graphs that we created in the previous section. Then we will look at a different search algorithm called depth-first search, and see how we can implement it. Finally, we will use the searching algorithms to solve a puzzle known as a sliding puzzle or an 8 puzzle. This video is called What Are We Searching For? In this video, we will see what it means to search a graph. We will discuss what we are looking for and what information we can find by searching through graphs. To search, in general, means to explore or to find something that we're looking for. This is also true for searching in graphs. When searching, we can either search the entire graph to explore the graph and gain knowledge about the structure of the graph, or we can search for a specific thing within the graph, usually a vertex that represents our goal state. So what exactly are we looking for? A goal state can be many things. It can be a geographic location, a solution to a puzzle, a node in a network. It all depends on what the graph represents. We might also want to gain knowledge about the problem that our graph represents. Take for example an airline that has to plan flights between cities. The airline operates out of 10 American cities. Due to the cost of opening new routes, the airline only has routes between specific cities. As a traveler from Los Angeles, we want to know where we can travel to. Looking at the adjacent cities to Los Angeles, we see that there are 3 flights out of LA, one to San Francisco, one to Las Vegas, and one to New York. But what if we need to travel to Seattle? There are no direct flights from Los Angeles to Seattle, so we have to search the graph in order to find out whether it is possible to travel to Seattle, and in that case what the best route would be. By searching the graph, we find that there is indeed a route to Seattle, but we have to travel through New York and Chicago before arriving in Seattle, which is quite a detour. Let's say that the airline discovers that a high number of travelers wants to go from Los Angeles to Seattle. So to reduce the travel time, they introduce a new flight from San Francisco to Seattle. Now travelers can travel from Los Angeles to Seattle with only one stop in San Francisco. In this case, the airline gained knowledge about the flights by searching the graph, and in conjunction with the high number of travelers from Los Angeles to Seattle, they decided to introduce a new flight route. So by searching, we can explore a graph and gain knowledge about the domain that it represents. We can use searching to find a path to a given goal destination, and we can use searching to find solutions to problems that we can represent as graphs. In the end of this section, we will see how we can use searching to solve the sliding puzzle, also known as the 8 puzzle. In this video, we talked about why we need to search our graphs and what information we can gain by searching.